Okay, this is 7.3, number 17. And I started to set up my sketch over here. And basically we're going to take the region bounded by the curves y equals x squared plus 1 and y equals x plus 3, which is a line. And the region bounded by those two curves, we're going to rotate that or revolve that around the x-axis. Try to find the volume of that solid. Okay, now if we look at this, this is my parabola, and it's just x squared plus 1, so it's just shifted up 1, and it's a standard parabola. And this is the line y equals x plus 3. And that just means that the intercept is 3 and the slope is 1, so I go up 1 over 1, up 1 over 1. So these are the two curves. Now we want to find out what our limits of integration are going to be, so we need to know where they intersect. So we can do that just by setting them equal to each other. They're both equal to y, so they're equal to each other. So x squared plus 1 equals x plus 3. Then I get everything to the left, and I get a nice quadratic. X squared minus x minus 2 equals 0. Easy to factor. It's a simple trinomial. X times x. The signs are different. Sign of the largest is negative, so I have negative positive multiplied to give 2, 2 and 1. There we go. So this implies that x equals 2 and x equals negative 1. So that's where they intersect, at negative 1 and at 2. So that's what we're going to integrate from, negative 1 to 2. So this is the curve that's going to go all the way around, so I can draw my reflection or my result after revolving it 180 degrees. And I penciled it in. Now if you use graph paper, you get a real nice sketch. I just try to be real careful when I measure this out so it would look symmetrical. So that's what it's going to look like, and you can see we're going to get these little discs here. Well, actually they're washers because we do have a big hole here. This is actually the inside I'm showing you. It's going to go from there, and this is the at 2. So it looks like this. It's kind of curved like this. It's kind of cool looking. But we're going to take the region outside here. That's what this is going to be, the outside part. And this is the inside. You can see the inside is what kind of looks kind of interesting. We're going to revolve that around. So what we're going to find is actually the volume of this outside part. And like I said, this is what we're cutting out of it. So it's almost like if we took this cone, because if we revolve that line about the x-axis, we would have a cone, and we're going to cut this part out. It looks like if you set it down, it would make like a coffee table or an interesting table. Okay. So the sketch is, pretty much most of the work. Should do that right. Okay. And we're going to take the outside radius, so that's the bigger radius. And again, from our washer method, now because we do have a hole here, a gap here, we got a big washer. All right. So this would be the washer method again. And this outside curve, or the top curve, this will be my big R, and the inside curve will be my little r. So that's easy enough to substitute in. So this will be x plus 3. And the other one is x squared plus 1. So this is your big R and your little r. And if we look at it, we can think of this as also the top curve and the bottom curve. Okay? That's about what we've got. So now we just have to, work it out. So once you have it set up, everything is easy from there. Again, we found our intercepts, or intersections, and this was at -1 to 2, so we're going to integrate it from -1 to 2. I pulled out the pi, because that's our general form for the washer method, and the big radius minus the small radius. Now we just have to go to work and do all the mechanics. So volume equals pi times the integral from -1 to 2. Pardon me. And we have to square this out, so we're going to get binomial squared, so that's just going to be x squared plus 6x plus 9 minus this one, and if I square that out, that's going to be x squared squared, which is x to the 4th, plus 2x squared plus 1, and that's all with respect to x. So volume equals pi times the integral -1 to 2, and then we can get rid of these parentheses so we can simplify it, so we get x squared plus 6x plus 9 minus x to the 4th minus 2x squared minus 1 dx. So volume equals pi times the integral from -1 to 2. And we can simplify this out. We got 1 negative x to the 4th and a negative 2x squared plus x squared is negative x squared. And I just have a little 6x here by himself. And 9 minus 1 is 8. Dx. Too bad we don't have any symmetry here we could take advantage of. Pi, and I guess we're ready to take the antiderivative. This is all set, so pi times, this is going to be negative x to the 5th over 5 minus x cubed over 3 plus, and that's going to be x squared over 2, and 6 over 2 is 3, so that'll just be 3x squared plus 8x. And we're going to do that from -1 to 2. And we've got some arithmetic to do here. So volume equals pi. And then I'll do the first part. Remember the fundamental theorem of calculus, f of b minus f of a, so I'll put 2 in there. And I get -32 over 5, -8 over 3, 2 cubed is 8, plus 2 squared is 4, 3 times 4 is 12, and plus 8 times 2 is 16. Minus, and then we'll just put -1 in here. So that's going to be negative times a negative, because if I raise -1 to the 5th, I get -1 times negative is 1. So I got 1 over 5. Same thing with the cube, that's another odd power. So that's going to be a negative times a negative is positive 1 over 3. And then 3 times 1 is 3. And 8 times -1 is -8. Okay. And then volume equals pi times, and I can simplify these, I just put everything into 15 except for the number, so I had -96 over 15. Multiply the top and the bottom by 3 and the top and bottom by 5, and -40 over 15 plus 28. And this is also over 15, so that's going to be 3 over 15. Top and bottom by 3 plus 5 over 15. And then -8 plus 3 is -5. And then I add up all these 15s, so volume equals pi. And if I add up all these 15s, I get -144 over 15 plus 33. And then if you put these all over 15, but you guys love this stuff, all this arithmetic. Put this all over 15, you get pi times, so make that over 15, so that's going to be negative 144 over 15 plus 495 over 15. This equals pi times, so 495 minus 144 is 351 over 15. And believe it or not, 3 goes into both those, so this ends up being, if I reduce that, that's up being 117 over 5. I divide the top and the bottom by 3 times pi, and that's your answer. So that's a bit of arithmetic there. You use your calculators to kind of take care of these numerators and add up these numbers, but it does work out. Okay, so that's number 17, and that was by far your most challenging problem on this assignment.